People put a z there, but you know that z is going to be equal to what? Y minus 100. So you know the perimeter of fencing, so the amount of fencing this Farmer Brown, the perimeter is equal to 2x plus y plus z. So if you replace that z, you get 2x plus y minus 100. But what is the perimeter for fencing? Like, this is the fencing we have right here. 180. So 180 is equal to 2x plus 2y minus 100. So 280 is equal to 2x plus 2y. So x plus y is equal to what? 140. So y is equal to 140 minus x. What's the area of that rectangle going to be? X times y. So the area is going to be x times 140 minus x. So before we do any differentiation, we end up with negative x squared plus what? 140x. So this right here is the area function we're working with. What are we trying to find? We're trying to find the max when x is between what? 0 and 40. So many of you went to try to find the actual maximum. Is the actual maximum this can be going to necessarily be in this range? No, you actually found it out. It's not. If you do a prime on this, you end up with negative 2x plus 140. So that'll be 0 when x is equal to 70. But that is not in domain, right? So all that tells you is that you're not going to be able to make the maximum area you possibly can with that domain restriction. So how do you figure it out? You take this, you take this domain restriction and you analyze that function. What does that function look like, everybody? What shape is it? It's a parabola facing up or down. Crossing the x-axis at what and what? Where does this cross the x-axis? So you have 0 is equal to negative x squared plus 140 x. What can you factor out? 0 is equal to negative x times x plus 140. So what are the two zeros? X is equal to what and what?
0 and negative 140.
Is it near negative 140?
I think so.
Oh, this has to be negative. I'm sorry. I don't know why I pulled that out. It should be x, negative x, and plus 140. So it's going to be that, and am I just doing this in circles? So I did want to factor out negative x, but if I factor out negative x, it ends up being x minus 140, right? So x will be either 0 or 140. So it's a parabola facing what?
Yeah.
Down, crossing at these two places. It goes up and it goes down, correct? You found out that where does that maximum occur? At x equals what? 70. So there's the maximum, right? But what x values are you allowed to have? 0 to what? 0 to 40. So where's the maximum going to occur? It's going to occur at x equals 40 because a prime is greater than 0 for x between what and what? The derivative is positive between 0 and 70. So between 0 and 70, it's increasing. So from 0 to 40, where is it highest? At 40. So it's going to be when x is equal to 40. The question asks, what should the dimensions be? So if that's true, we know that y is equal to 140 minus x. So what does y equal? 100. So the answer to this question is 40 by 100. Got to be careful. You got to be careful. You got to be careful. Okay, please get back to the board. So what is this section going to be right here? With given the variables, what's that blue section going to be labeled? Y minus 40. And then this green section right here is going to be labeled what? X minus 20. Right. So then you know your perimeter is going to be what? X minus 20 plus y plus x plus what? Minus 40. How much is 80 feet of fencing? So how many x's do we have? We have x and x, so what do we have? 2x. How many y's do we have? 2y minus what? 60. So we have 140 is equal to 2x plus 2y. So x plus y is equal to what? 70. I got to actually do the division. 70. Nice. And maybe y is equal to 70 minus x. And what's the area function going to be? What's the area function going to be? The beginning of it. X, X times Y, right?
Yeah.
X times Y. So area is going to be X times what?
7 times X.
So you have to find this maximum, find the maximum, when does it occur, given the domain restrictions. You're not actually given the domain restrictions, you have to figure them out. So basically, before you go any further, you should figure this out right here. What are the domain restrictions for X and Y? What's the smallest X can be? What's the smallest X could be?
20.
Smallest X could be is 20, right? What's the smallest Y could be? 40. So this is what I'd like you to try to figure out, everybody. Do this by yourself right here. This equation right here is written in terms of X, right? So many of you did this. I saw you guys do this. A of X is negative X squared plus 70X. So what's A prime equal to? Negative 2X plus what? 70. So how many of you had something like this at one point? Something like that? So you got X is equal to what? 35. So that's where the maximum would be, but can X be 35? No. So the question is, what X value should you choose in order to maximize the area? Well, what does this look like? What does this function look like? Parabola facing up or down?
Down.
Down, and it crosses at 0 and
Then
70. It goes up like this. That's a terrible parabola. I'm sorry about that. Something like that. And where's the maximum occur? But can X be 35? No, it can only be from what to what? 20 to 30. So 20 to 30 is like right there. So 20 to 30, where does the maximum occur? When X is 30. When X is 30. When X is 30. So the max on domain is X equals 30. But if X is equal to 30, what does Y have to equal? Well, we know Y is equal to 70 minus X. So Y of 30 is 40. So the answer to this would be X is 30 and Y is what? 40. Did we actually need to use the Y domain, the restrictions on Y? No, not in this case, but we could have. Why? We said Y could go to be 50. Goes out a little bit like this. So that would be 50. This would be 20, but then this would be 10. What's 50 plus 20 plus 10? Exactly. So that's the maximum. And if this was stretched any further this way, it would add to this number and this number, which would add together all three to be greater than 80. So what's the maximum? X can be 30. What's the maximum? Y can be 50. So then we use that information. Everything was in terms of X, so we use this restriction, and it turned out to be, it happens when this is 30 and Y is 40.
Right.